Okay, resultant force. I have this session recorded down. If you are lagging later, you can watch back the recording. Okay, now let's start with a little bit of review of what we learned last week. Okay, so let's say just a short one. I have an object. I push with force 10 Newton. Here's 5 Newton. 10 people pushing to the right, 5 people pushing to the left. Where does it go? To the right. So this thing will go to the right with a net force of 5 Newton. OK， 10去右边，5去这边，我们拿掉5，我们剩下5。这个剩下的 force 啊 ，after 你减其他的那种 force， 剩下的它是我们的 result 对吗？我们的 result， 所以我们叫它 resultant force。另外的一个字我们用就是 net force， 一样的 meaning。Okay, so this is the resultant force. Now, let's say 这个是5 kg. If you have a resultant force, according to Newton's law says that F equals to md. That is the Newton's second law. That means if you have a resultant force, 这个是 F net, then you will have acceleration. I can calculate the acceleration of this block. A equals to F net over m. Okay. 5 over 5, that is 1 meter per second squared. Now, 现在我的 block 有 acceleration 1 meter per second squared. Acceleration 是 vector 对吗？它的 direction 在哪里？它的 direction 是跟着 net force 的 direction. Again, acceleration 的 direction 是跟着 net force 的 direction. So if your net force is here, then this thing will accelerate here with an acceleration of 1 meter per second squared, like this. This one, when I do the calculation, this net force, I do not put this one. No. This one? No. I put the net balance. Okay? Even though it's the same value, but you need to know that this is the resultant I always put. This is common mistakes. A lot of students, they take this. This is individual forces. One force, this is combined. Okay? Now, another example. This one, same object. And then I say there's a force pulling it 4 Newton. And then down, 3 Newton. These two forces, they are not in the same line. This one is asking to go here, this one is down. So if you, at the same time, apply this force, where will this thing go? This thing will go. From our last lesson, we can find the resultant, right? Taking the 4 Newton, I take it, put it somewhere I can draw. Then I will take the 3 Newton, continue from here. Okay, so down from here, 3 Newton. This is 4 Newton. This one plus this one. What I'm doing here, I'm adding the forces. Because they are not in the same direction, so the way I add the forces is using head to tail. You can see that I use the head of the arrow joined to the tail. Okay, this one. The head here joined to the tail here. So I start here, I end here. The resultant is going to be starting to ending. F net. This is resultant. 把它想象成 journey， 我可以走这边走下来，或者我可以拿 shortcut， 直接走这边。This is my net force. Okay, so how much is this net force? You can also calculate here. 4, 3. This is a right angle triangle. So you can do this square root 4 squared plus 3 squared equals to 5 Newton. Okay, so 5 Newton is my net force. Now, when there's net force, there is, back to this one. When there's net force, there is acceleration. So this block, now it has a net force. That means when you take this and this, you combine them, you add them, then you get a force total net 5 Newton. That means that 这个 net force 会 accelerate 这个 object 去哪里？去这个方向。Same acceleration, same direction as the net force. So acceleration can be calculated by acceleration F net over m. 5, same. Okay, 5 kg. 1 meter per second squared. Where's the direction? You label the direction. This direction is same as this direction, A. Same as the net force direction. This is 1 meter minus squared. See the difference, huh? This one and this one. Acceleration is like this. Always follow net force direction. Always follow net force direction. What is net force again? It is the combination of all the forces acting on the same object. So here we will define what is Newton's second law of motion. 你的 note 第一个 Newton's second law of motion states that, okay, 写进去，把这个写进去。Number one, Newton's second law of motion states what? When the net force acts on a body, the body accelerates in the direction of the force. And then, from this formula, 如果你的 acceleration, sorry, 你的 net force 越高，你的 acceleration 越高。So we put it here. The acceleration is directly proportional to net force. Keyword, when net force acts, 这个一定是 net， 不是 individual forces。如果你的 object 这边是2 Newton， 这边是2 Newton， 2 Newton 去右边，2 Newton 回来，你的 net 是多少？两个推去右边，两个人推去左边，到最后是没有东西，所以你的 net force 是0。In this case, your net force is 0. So here, when a net force, there must be a, like this one is 5, this is 2, then you will have a net force. Okay, so when a net force acts on a body, it accelerates in the direction of the force here. Same direction, the acceleration is directly proportional to the force. That is Newton's second law. This one, the first point. Okay. Now, 现在我们看 net force. Point number 2. A net force or resultant force is the what of all forces acting on a body. Write down net force is a vector summation. Vector summation. is vector summation of all forces. What do I mean by vector summation? Summation 就是加吗？加起来 ，vector summation 呢，就是我们不是就这样子加罢了，我们是要看 direction 来加。我们拿一个 example，let's say 这一个10 Newton 去右边，这个是 positive force， 5 Newton 去左边，这个是 negative force。So 如果我要把这个两个 force 加起来，我会写 sum of force sigma， 这个我们叫什么 sigma？OK， 也就是讲 sum 的意思 ，total 的意思。Total force 是等于我把这个两个加起来 vector summation， 就是说你要放加或者减，10加10n， 这个是减，加减5n。Like this. So this one plus minus, so you get minus. This one is you get plus 5n. 你的 last answer got a plus. That means your net force is to the right. To the right. That is your net force. Okay. So for this one, how do I add these two forces? Here I have shown doing the head to tail method to add the two forces. Okay, so point number 2, a net force or resultant force is the vector summation. 如果问题问你啊，你 copy paste 这个东西给他。OK， 那第3，那现在我们看这个啊 ，Let's say， OK， 如果我有 ，Let's say 我有一个 object， 然后5 Newton， 5 Newton， forces are balanced. Is there net force? There's no net force. So I will write here F net 0. Now, when there's no net force, what about the acceleration? F equals to ma. This is 0. Ma, so A is also 0. When there's no net force, acceleration is also 0. Now, 当我讲 acceleration 是 0 的时候，是什么意思？ There are two scenarios where acceleration is 0. First is that object is at rest. Acceleration 0代表 object 是 resting. 还有另外一个情况 ，OK， 还有另外一个情况就是 ，Let's say 我推这个东西5 Newton。I apply the force 5 Newton and the object is moving. It is moving at constant velocity. Constant v. OK 啊 ，constant v. 然后它的 friction. Let's say this is a rough surface, and then we got a frictional force under here, 5 Newton. 你推它5 Newton， 然后那个 friction 是5。What is the net force? 0. 0 net force, 0 acceleration. But is the object at rest? It's not at rest. The object is moving at constant velocity. So that means when I say acceleration 0, it's not necessarily that it is at rest. It can be moving, but it is moving at constant velocity. F net 0, acceleration 0. What happened to the object? Object moving constant velocity. Scenario number 1, scenario number 2. These two scenario is when what? When no net force. You can write this one down. In note number 3, the space down here, you can copy down for your future reference. Okay. So point number 3, if the net force is 0, acceleration is 0. Object is either moving at constant velocity, that's scenario this one, or stationary. Stationary means at rest lah. Okay, it's either doing this or doing this. Now, a lot of students, they forgot this one. When they see net force 0, straight away they think, okay, it must be at rest. No, you have another situation like this one. Let me give you another example, one more. 我丢一粒球, okay, I drop a ball from a certain height, I drop it. What is the force acting on the ball? We got weight, W. Acting on the ball. Is there other forces acting on the ball? There's air resistance, right? So, going up, air resistance, Fr. If the weight of the ball is 50 Newton and the air resistance is 50 Newton, what happened to the ball? 那我一开始丢它的时候，它的 speed 是很小，对吗？ The longer it falls, the faster it moves. That means the air resistance increases with the speed. Increases with speed. 你一来我丢它的时候，它走得很慢，它的 air resistance 是很小，可能是 OK 5 Newton。然后越走越快，这个增加。 5、10、15、20，直到50。So this one increases with speed until it becomes 50. What happened to this ball? Does the ball falling suddenly it stop like this, mid-air? Okay? 它跌，它可以突然间这样子停吗？没有这样的东西。Cannot. That means when this force equals to this one, then what happened to the ball? The ball has to keep on moving, but the ball is falling at constant velocity. That is when this one, same as this one. What happened to the ball? Fall at constant v. Constant velocity. 这个我们叫什么 velocity? 我们叫 terminal velocity, 对吗？在你的 Weight chapter, first chapter, terminal velocity， 就是它继续走，可是它的 velocity 不会再增加，不会再增加 constant velocity. So this is also what is the acceleration? Net force 是多少 ？Net force 是50上去，50下去，减掉0。 所以这个也是真的来的 ，no net force acceleration 是0，它在做什么 ？acceleration 0，它是在 rest 吗？它不是在 rest 啊，它是在 moving but constant velocity. So this one， 明白吗 ？OK 吗 ？OK 啊 ？So the keyword, okay? So what I want you to take away from here, the key takeaway is that when the question says no net force, there are two situations, rest or object moving at constant speed. Okay, that's it. That is point number 3. Okay, you can draw this one and this one inside here. Okay, right. A wooden block is resting on a surface. What is the forces acting on this thing? Let's label all the forces up. Okay, let's see what are all the forces acting on this particular object. So first thing we have the gravity. Now, 这里有两个 body， 第一个是那个盒子，第二个是那个 ground. We got two bodies. One is the box, one is the ground. So the gravity of the earth is pulling on two objects. I repeat, the gravity is pulling on two objects. So that means we have this one. What do we call this? This is the force earth on object. Okay, now there's another one. This one is acting on the ground. F, earth on ground. Okay 啊，因为 gravity 是它 act 在全部东西在 surface on the earth. Every object is subjected to gravitational force. So if I have two bodies, then I got two forces pulling them. Even the ground also. Okay, now, when this block is pulled by the earth, what happened here? Let's say I take this thing, I put it on my hand like this. This weight, I'm feeling the weight. This calculator is being pulled down by the earth towards the ground. So it's pressing my hand, right? It's pressing my hand. So it presses my hand. If I want to keep it in this position, then I have to apply a force upward as well. Again, if I let go like this one is falling because there's a force pulling down, right? If I put my hand here, I'm preventing the object from falling. So that means I'm also applying a force. This force, what do we call it? This one, the block is pressing on the ground. Then the ground is preventing the object from falling. That means the ground must be applying another force as well. This force is applied on the block. We call it the reaction, right? The reaction R. Who is applying this? This one is from ground. Without the ground, there's no reaction. So this thing will be falling. If I remove the ground, left only the object, I remove the ground. What is the force left? Left only F, earth on object. When the ground is not there, this one and this one disappear. If the ground is there, then this one is there. Okay, so what causes reaction? This is by preventing this thing from coming down, so it acts a force upward. Okay, now 这里我们有3个 force。如果我要 analyze, let's say 我要做一个 analysis of forces. I have to choose one object, and then I want to draw the free body diagram of the object. What is a free body diagram? Free body diagram. 如果 imagine 我把这个盒子拿出来，没有那个 ground 呢，我只是拿那个盒子出来，单那个盒子我把它画在这边。多少个 body? This is only one body. Okay, one body. Then 我要拿哪一个 force？ 这个 force 是 acting on the box. This force is also acting on the box. What about this one? This force is acting on the ground. But I only want to look at the box. So that means the two forces left, I need to label here is the F, earth on object, and the R here, reaction. 这个我丢掉，我只剩下这个，因为我只是要 show 总共的 force acting on 我这个 body， 其他的 body 我不 care。Okay, I do not care the forces acting on other body. I only want to know the forces acting on this particular body. So this diagram, we call it the free body diagram. Why do we call it free body? Because I make this body free from the system. Here I got a system of two bodies. I make one free, take out. So I call it free body diagram. This is the free body diagram. So what is a free body diagram? A free body diagram is a diagram that shows all forces acting on that body. A free body diagram, FBD. A free body diagram shows all forces acting on that particular body. Other body, we do not care. Okay, so if the question asks you, draw a free body diagram, then you know what to do. Take the object, show all the forces acting on the object. You get the free body diagram. Okay, so in this example, we do not show this because this is on a different body. Right, so the note number 4. Oh, number 5. Look at number 5 first. What? A free body diagram. Okay, number 5. A free body diagram. 然后你写 FBD of an object is a diagram that shows all the forces acting on that object only. And then a free body diagram is necessary to analyze the force acting on a particular object. 意思说，如果我要找它的 acceleration 啊，它的 mass 啊，我首先一定要画它的 free body diagram。OK， 然后我就用这种 FMA 找它的 acceleration。等下我会 show 你那个 example。OK， now 然后你看啊，第5下面这边 types of forces to label in a free body diagram。OK， 这个5种把它背起来，哪5种？第一 MA、MG、FTR。MA is the resultant，F 等于 MA 嘛，对吗？所以 resultant force。MG 是 weight 哦，然后小的 F 是 friction， 然后 T 是 tension，R 是 reaction。所以我把它 short 成 MA、MG、FTR。F 等于 MA、MG、FTR， 这个5个把它背起来。为什么呢？你每次画 free body diagram 的时候， 你在你的脑一直走这一个 MAMGFT 啊 MAMGFT 啊 ，make sure 你 label 这全部5个。有一些情况可能 friction 没有，这样你就要 label 其他咯。有一些可能5个都有，所以在这个情况下，你有什么？你有 R reaction， 你有什么？你有 W，Earth on object 就是 W 啦。weight， 意思说你有 R， 你有 mg， 因为这个是你的 W 等于 mg 嘛，对吗 ？OK， 你有 F 吗？这边没有 F， 没有 friction， 因为它在 rest 嘛。Tension 是 related to string. If you have a string, like you hang something, you take a string, you hang an object, there will be a tension in the string. So tension is for the string one. So if your diagram doesn't have a string, then there's no tension. Okay, and oftentimes the R is related to surface. 如果你的 diagram 有 surface, like the ground, then you will have R. Okay, so now let's look at other free body diagram. Okay, 你画几个进去？第5 point number 5的后面，第2面你看到 example of free body diagram. Okay, 画几个 example 进去。First one. Let's say I want to label the free body diagram of. Okay, we have our first one. So the first one is the W and the R. So 这个是 W, 这个是 R. This is the first one. 看到吗？这个2个 force 是 act 在哪里？这个 block 啊，因为这个我们丢掉啊。我的 free body diagram 只可以 show 一个 object, 一个 body. So this is the block. W and R. Number 2, what are other examples of free body diagrams? Okay, you can draw, let's say we have a car. We have a car moving on the road. Okay. Label free body diagram. Okay, 我们 run through 这个 list MAMGFTR. Let's say 这个 car 是 rest. 如果它是 rest, 意思说 acceleration 是0。Okay, resting acceleration 是0。Net force 是多少 ？Net force 也是0嘛，因为 F 等于 ma， 这个是0，所以0哦。所以你有 ma 吗？你没有 ma。You don't have ma, so we cross out the ma. Trust God. Trust we just use a general F. Yeah, we just use a general F. Okay, we can just write F. Yeah. Okay, now MA 没有哦，所以我们不用 label MA。好，现在我们去 MG， 有 MG 吗？一定有咯。MG 这边中间 MG。OK， 然后 F friction， it is at rest, no friction. T tension string, there's no string. Surface R, there's a surface, so there must be R. Okay, it's the same thing as this one. 那么如果我讲那个它是走着的呢？ Okay, like this. Constant V. Moving. Then we will do mg R. 还有什么？ Like Andrew mentioned just now, the truss, right? Truss. Just write F like this. thrust F. And then it is moving. It's moving, that means we have friction. So friction, how you label friction? Label at the ground. Friction, the way you label is always between the surfaces. So here. And friction is always opposes motion. So if your motion is going right, your friction is opposing against it. Small f, like this. Okay? Now, 所以我们有多个4个 mg r t f, and then this is just f force f. Reaction, okay, this one done. Tension, there's no friction. Do we have MA? Do we have MA? You see this constant V. Constant V is the acceleration. Acceleration is 0. So there's no MA. So 你的 free body diagram 就这样咯。然后你的4个 force 就是 acting 在同样的 object. Okay, 同样的 object. Okay, let's do one more. How about this one? How do you label this? We have a slope, and then we have the object. The object is not sliding, huh? So rest. Okay, now 我们先 label MA 有吗？ Not sliding rest 所以没有 MA。MG 呢 ？MG 有，怎样 label MG？ 中心。You must be acting from the center of the object and then vertically down. MG. This must be vertical, not sloping. This MG should be pointing to the center of the earth. Right? So this is the earth. If you're here, the MG should be like this. MG. If you're here, the MG should be like this, pointing to the center. But since the object, every object is very, very close to the ground, then we just point vertically down. We just assume the center is over here, okay? Now, second one, F, do we have friction? Now, 这个是 tricky one. Do we have friction? Yes, we have friction, because without the friction, this thing will slide. It is because of the friction that is holding the thing up here, right? Even though it is not moving, but if there's no friction, then this thing slides down, right? So that means there is a friction. How do you label the friction? You imagine this thing sliding down, the friction is opposing. So this slide down, then the friction go up. F. Okay, this one done, this one done, this one done. Tension, there's no tension. Okay, last one, reaction. Reaction, the way I label reaction must be, this one is normal to surface. When you label reaction, it must be normal to the surface. Where is my surface? This is my surface, sloping one. So how do you draw a normal to the surface? Here, I take a ruler. You take the sharp corner of the ruler. This is 90 degrees. Put it like this. This one line up with the slope. This one will give you 90 degrees. Like this. Oops. Reaction. 这边是90度。OK， 把去到中间了，去到中间。Yeah. So reaction is 90 degrees to surface. So this is your free body diagram. Is there anything left? You already run through everything. There's no more. That is the answer. Okay, did you draw this 1, 2, 3, 4 in your paper? Have I shown the tension one? I've never shown the tension, right? So tension very easy. Okay, let's say I hang an object like this. I hang the object like this. Rest. We have a string. That means we have a tension. How do I label the tension? The tension, 你 imagine 我的 string 这里有一个 particle, the last particle of the string. Imagine the last two particles. This object is pulling this particle down, right? It's like they are trying to separate these two particles. And then this particle here, it says cannot, I want to come out. Okay, the particle says I want to come up. Then the coming up produces a force to be labeled out. Tension. Coming up or coming out of the object, because the object is pulling it down, right? Object pulling it down, this particle says cannot. I want to put it back up. So the force created is up. Yeah. So tension is always labeled. How do I label? Out of object. We say coming out of the object. So if this is my object, out of the object. Yes. The ceiling. How do I label tension? Coming out of the object. So down. Coming out of the object. So this one come down here. Now, 这样你问，这样是不是有两个 arrow 在同一条线 ？Yes. Tension 是 always 两条的。OK， 意思是说，如果我拿一个 object， 然后这样子，怎样 label tension 在这个 string？ 我们有两个 object 对吗？我们先看这个 object。Out of the object， 然后你看这个 object，out of the object，so that's your tension T。Okay， so 如果你 pull 这个 ，then force is preventing like this. So this is example for tension for the free body diagram. Okay. Anyone still copying this one? Okay, right. So after we learn the FMA, free body diagram, now we look at one real life situation, the elevator problems. So far we have understood if I stand on a surface, the weight is pulling me down, and then I also experience a reaction. When I stand, I feel like something is pushing my body. That is the reaction that I'm feeling. Can I feel my W? The weight. You are not feeling the weight. You are feeling the reaction because the ground is pressing you, right? Okay, when you stand, right? I'm feeling something is pressing me. The ground is pressing me. So the one that gives me the feeling of my own weight is actually the R, not the W. Imagine if I remove the ground. If I remove the ground, then what happened here? There's no ground, so the R will disappear. Left only the W, right? When you are falling, can you feel something is pressing you? When you are falling, you cannot feel, right? When you are falling, you feel like you're weightless, right? You have been on a roller coaster or a free fall bungee jump. When you are falling, you cannot feel your own weight because there's no reaction, there's no R. The R disappear already. Okay, so that means this simple thing proves that it is the R that gives you the sensation of your own weight. Now, which means anything changes to the R, anything changes to the R will cause the feeling of your own weight to change. Why sometimes we feel weightless and sometimes we feel we are very heavy? For example, when you sit in the elevator, when you stand in an elevator, at first you get in the elevator and then the elevator goes up. As it starts moving, you feel like you're very heavy. The ground presses you very much. And then when the elevator stops, you feel like you're very lightweight. Okay? Or it can be when the elevator is moving down. When you go from 10th floor to ground floor. When the elevator is accelerating downward, sometimes you feel like you are lighter. Okay? You feel like you are lighter than you really are. Okay? Why is that happening? We will see in this scenario. Okay? It is something to do with the R. Because the R is always changing during the elevator moving. Okay, so now I will take 3 situations. This is my elevator. Here, this is me. I will take 3 situations. First is when the elevator accelerates. And then when it is moving at constant V. And when it is decelerating. Okay, I want to go from ground floor to 5th floor. At first, it accelerates, and then constant velocity, and then decelerate. We will see these 3 stages. Now, I will call this stage 1. This is stage 2. And this is stage 3. Okay, let's look at stage 1. What happened during this stage? Okay, we can draw free body diagram. We draw what? Free body diagram. Okay, 在 stage 1的时候，我的 free body diagram 这样子。This is me. Stage 1 is constant V. So constant V. Going when? Going up. Now, label 你的 free body diagram F 等于 ma mg ftr constant velocity 有 ma 吗？没有 constant v acceleration 是0 cos mg F there's no F tension there's no tension here I'm looking at my body not the lift the lift has a string right here you got tension but I'm only labeling the free body diagram of the person so there's no tension is there reaction on the body of the person yes because you have a surface so R is here now no MA, so I will write MA equals to 0. Okay, now, 当 MA 是0，你的 net force 是多少 ？F net 是 MA， 这个整个等于0，你的 F net 就是0哦。如果你的 F net 是0，将 R 跟 mg 加起来是等于0。记得 net force 是什么吗 ？net force 是 vector summation. If I add these two forces, I get the net force. So when I add these two forces, since the net force is 0, when I add these two, it becomes 0. That means sum of forces equals to 这个走上去是加，走下来是减。所以当我加这个两个 force 的时候，加 R 加减 mg。OK， sum of forces 这个就是 net force 等于0等于 R 减 mg。然后我把这个搬过来 mg。OK， 我直接把它这样写 R 等于 mg。先把它 box 起来先。This is the one that I get. This is showing that the reaction that I'm feeling is the same as my weight at constant velocity. That means during stage 1. This is what happened here. Okay? Now, let's see stage 2. What is happening here? Accelerating. Okay, let's draw the diagram again. We have the accelerating upward, right? So I will draw acceleration A upward. Now, label your free body diagram. Do we have MA? Yes, we have MA. So you got acceleration, that means you have MA lah. So MA is going up. So I label MA. MA going up. Okay? MA 就是你的 resultant force 吗？对吗？ OK, mg 跟这个一样吗 ？mg， 然后 F 没有 ，T 没有 ，R going up。OK， 我们有3个啦，我们有 mg、R 还有 MA。OK 啊 ？OK, now what do we do now? Do we have resultant force? We have resultant force. It's going up. And then we have this two, right? Label the sign. This is a positive force. Negative. What is my MA? Positive. So I take the sum of forces equals to 这个是什么？加 plus R plus minus mg. OK， 跟这边一样吗？plus r plus minus mg， 然后呢，这个是我的 net force 吗？意思说我把这个换去我的 ma plus， 所以这边是 ma 等于 r plus r 减 mg， 可以吗？再来啊，慢一点啊。我已经画了那个 free body diagram 是，我找什么？我找sum of forces，vector sum of forces。OK，vector sum of forces 就是我把全部 force 加起来，这个 r 再加减这个 mg， 然后这个就是我的 net force 吗 ？net force，so it is my ma。我拿到 ma 等于 r 减 mg， 我 arrange 一点点 ，r 是等于这个搬过来 ma 加 mg。OK， 我 box 这边这个 r equals to ma plus mg。这个跟我讲什么？当 lift accelerate 上去的时候，我的 r 是等于我的重量再加 ma， 意思是说这个 r 是大过我的 mg 哦，对吗 ？This r is bigger than my mg because this is added to another one. The reaction is bigger than the mg when the lift accelerate up. If I'm feeling the reaction, if the weight that I feel is the reaction, then I will feel that I'm heavier than I'm actually is. That is why when the lift accelerate, you feel like you are heavier because the R is ma plus mg. When the lift is moving constant, you feel the same as your own mass, okay? So if it's going up, then you feel that you are heavier. This one because the reason. Okay, so stage number 3. Decelerate, going up. 同样的 free body diagram. Decelerate 的话，我的 acceleration 向哪里 ？Decelerate 我 acceleration 向下。Okay, this is moving up, but my acceleration is going down. That is deceleration. Okay, so where's my ma? Ma is down. Okay, ma is down. Mg 一样，然后 r。Okay, summation of forces 这个是加，这个是减，这个是减。Sum of forces 等于加 r 加减 mg， 然后这个是我的 net force 来的吗 ？Vector summation 对吗？所以我的 net force 就是我的 ma 咯，减 ma 减 ma r 减 mg。减 ma 加 mg 等于 r， 所以 r 等于 mg 减。What does this tell you? the weight that you are feeling is less than your actual weight. This is your weight, mg. You minus something, so the R becomes smaller than your real weight. Since this is the one that we are feeling, then I will feel that during this stage, I feel like it's lighter. So in 3 situations, your R changes, right? This one changes. That is why when you step in an elevator, you always experience different sensation of your weight. This is proven using, what do we do here? We are still under the chapter FMA, resultant forces. OK， 我这里在做什么？我画 free body diagram， 然后我做我的 analysis。OK， 我的 analysis， 我可以用这个来找 acceleration。G 你知道了吗 ？G 你知道了？如果我知道它的 acceleration， 我的 mass 我就可以知道我的 R。OK， 一样的，如果它给你 R， 你也是可以知道你的 acceleration 是多少。This。对啊 ，so 另外一个方法，你可以把它想象，如果你觉得 OK 还是有点confusing 啊 ，OK， 你也是可以把它想象成这样子。如果这边的 acceleration 是向上，对吗 ？Net force 在哪里 ？Net force 是向上哦。OK， 跟 acceleration 一样嘛 ？acceleration 跟 net force direction 要一样啊。如果 net force 是向上，哪一个比较大 ？R 比较大，还是 mg 比较大？如果 net force 是向上 ，then 你的 R 一定是大过你的 mg。Imagine 5减掉5，你拿到 balance，OK， 是向上嘛？所以我这边我可以写 R 是大过 mg。OK， 所以当我做我的 F 等于 ma 的时候，我的这个 F 这个 net force 我是 sub R 减 mg 等于 ma， 我都拿到同样的东西，搬出去拿到这个。OK， 再来啊，当然这个 object，let's say 如果我讲这里是10牛顿，这里是2牛顿，我的 net force 是10减2，所以我的 net force 是上去8牛顿，大减小 ，OK， 然后那个剩下的 force 就是我的 net force， 8牛顿上去。那如果我突然间我讲，我不知道这个是多少，这个是 x， 这个是 y， 然后我跟你讲我的 net force 是向上，这样哪一个比较大 ？x 大还是 y 大？我的 net force 是向上，对吗？所以这个一定是大过 y。我知道 x 大过 y。OK， 所以我的 net force 是 F 等于 ma， 是 x 减 y 等于 ma。这个就是我在这边做的。OK， 这个同样的在这边 ，net force 是向下，哪一个比较大 ？R 大还是 mg 大？我的 net force 是向下 ，mg 大过 R。So 如果我用 F 等于 ma， 这个就是大减小 mg 减 R 等于 ma。然后你把这个搬过去，你也是拿到同样的这个。 Okay, now, if you haven't already taken down this, please take down this stage 1, stage 2, stage 3 in your elevator problems here. And then we are going to look at example 1 after this. Okay, we look at one example one down here. 80 kg man stands on a scale inside an elevator. What is the weight in Newton that the scale reads when the elevator is at rest? 80 kg man stands on the scale. This is the scale. What is the scale read when it is at rest? This is like the elevator problems. The scale reads the what? The scale reads the R. The scale reads the R, not the mg. So any changes to the reaction force will cause the change in the reading of the scale. So during rest, that is stage 1, right? Oh no, this is constant V, right? But at rest, we have mg, we have R. Do we have MA? Acceleration, rest, acceleration 0,所以 MA 是0。MA 0 net force 是0 ，OK？ net force 是0，所以如果我拿 sum of forces 加 R 减 mg， 这个是0 ，R 减 mg，R 等于 mg。So 如果你要找那个 scale reading， 我就找它的 R。80乘10， 800。Newton。Okay, B, moving upward at constant speed of 5. We create the same diagram. Moving upward with constant speed. So V 等于5 meter per second. Now, constant speed moving up, you MA 吗？没有 MA。记得我的 acceleration 等于0有2个 situation 吗 ？OK， 你的 point number 3 啊 ，point number 3， when acceleration is 0, object is either moving at constant velocity, which is this one, or stationary. So here the acceleration is 0. Acceleration 是0，你的 net force MA 也是0。同样的，我找 sum of forces 加 R 减 mg， 这个是0。OK， so R 等于 mg， 也是800 Newton。不管它 rest 或者它 move constant velocity， 你的 result 都是一样800。C, moving downward at constant speed. The same thing. Moving downward. If you recall, you can switch off yourself. Huh? You turn down the aircon. Yeah, just control any temperature you like. Okay. Now, here, this is moving down at constant speed of A. Same way, free body diagram. mg, R, A 0, MA 0, R 减 mg， 拿到也是一样，也是800。所以不管它的 velocity 是多少，5啊、8啊，总之它是 constant velocity 了，你就是用 R 等于 mg 了 ，OK， R 等于 mg。Okay, please do not memorize this. Don't memorize it. Understand how you get this. Why I write this. Why I write this. understand here. Okay, there's no memorization needed. Okay. And then B. Moving with upward acceleration of 3. Okay, now you have acceleration. Free body diagram, mg, r. Okay, you got A. This one in the MA 是向上。Sum of forces equals to positive, negative, this is positive. So positive R minus mg. This one is a positive MA. Okay, so 你看80 kg 乘 acceleration 3加80乘10。1040 Newton. The scale reading is R. Yeah. The scale reading is R. Okay, last one. OK， 那 concept 是一样的，意思是说你可以 apply 这个在其他的 situation，let's say a suspended object, and then this object is raised up with an acceleration of 5 kg. Question asks you to find what is the tension in the string. Same thing, we can apply the same concept here. Free body diagram. Okay, some of you cannot see. I will write it here. We have a suspended object that is raised up with an acceleration of 3. Find force in the string. So we do the same thing here. We first label the free body diagram. Here is my mg. You have a string, you have tension. How do you label tension? Out of the object. Out of the object. Like this. T. Here there's no object, so I just label here. Okay. Acceleration, so you have MA. MA is going up. So this is a negative, this is a positive, this is a positive. Sum of forces. So positive MA is equals to T minus mg. T is MA plus mg. 拿到这个了吗？我们之前做的是什么？我们做的是 R 对吗？你看 method 是一样，我只是换这个变 T 罢了。OK, so T 等于 MA 加 mg 等于5 kg into 3 plus 5 into 10. So 5加50。65 Newton. Force in the string, 65. Or 我也可以这样子问你 Let's say 我拿同样的东西 5 kg acceleration we don't know, and if I say the maximum tension is available is 18 Newton. What is the maximum acceleration? The maximum tension available, that means the string snaps at 18. The string snaps at 18 Newton. What is the maximum acceleration allowed? This one also it can be asked like this. So how do you solve this? Same way. Okay, so max tension available is 18. So again, we draw the free body diagram. W, mg, tension, ma. 一样吗？对，跟这个一样对吧？所以我直接拿这个吗 ？T 等于 ma 加 mg。OK， Same with this one. Then what I want to find, the maximum tangent available is 80. So this one I put maximum 80. If I put 80 here, maximum, then that means the acceleration that I calculated will also be the maximum acceleration. Yes. Here we do m over a plus g. M is 5, acceleration plus 10. 80. Like this, right? Then this one I bring it here. 16 equals to a plus 10. A equals to 6 ms minus 2. Yes, 6 ms minus 2. Okay. So this one you can